All right, factoring trinomials where a equals 1. And so when we have x squared plus bx plus c, there's an a here. When that is 1, these factor fairly nicely relative to ones that we'll do in the next unit. So I've given you a sort of a form here on how we're going to be factoring. I think it's easiest for me just to explain what we're going to do here. And again, if we can't find numbers that work, they're prime. So if it can't be factored, we just call them prime. So with that said, let's look at this first example here. X squared plus 7x plus 10. So what we're doing here is looking for factors of 10. We're wanting to factor these trinomials into two binomials. So let's start here. So we know when it's x squared, what times what is x squared? Well, the only way to factor x squared is x times x. Those are nice. Now what we do is we look for factors of 10 that, so again, numbers that multiply to give me 10, but then when I add them, I get the middle term. So I only have two possibilities. It can be 5 and 2, or it could be 10 and 1. And so there are various ways to organize these in tables to come up with these. I'm just going to use a little factor tree and just sort of do it mentally. So which one of these sums to 7? Well, 5 and 2 sum to 7. So there's the ones I'm going to use. So this can be plus 5 and plus 2. Now, why does this work? So it doesn't seem so random. So x times x is x squared. We're just checking it. So this is the final answer. X times 2 is 2x. 5 times x is 5x. Then 5 times 2 is 10. So notice what we did here for that 10. Let's sort of just unpack that a little bit. We find numbers that multiply to give me 10. But notice that I'm going to always multiply this out the way we did there. And so I'm trying to find numbers that add to give me that middle term. Okay, how about this next one? X squared minus 9x plus 20. So again, I'm going to start it off. X and x. Now later on, this will be something other than a 1, and it could be 2x and x, or 3x and x. And it makes it a little bit harder. So now I'm going to do my little factor tree, so 20. And it is worth writing these down. I see students all the time just sort of thinking about all the factors. Now sometimes you can do them pretty quickly, particularly when they're all positives. But when I get a negative in there, let's go ahead and write some stuff down. So factors of 20. So what do we got here? 4 and 5, 2 and 10, 1 and 20. I think that's it. So all these multiply to give me the 20. But how about when I add them? So when I add these together, so 4 plus 5 is 9, 2 plus 10, 12, 1 plus 20 is 21. Well, I'm looking for ones that add to be a negative 9. So when it's negative 9, if both of these are negative, two negatives give me a positive, that adds to a negative 9. So that is the answer, x minus 4, x minus 5. So one thing to note, you don't have to know this, but it does come out nice. When this sign here is positive, the sign of your C term is positive, we know that my factors are going to have the exact same sign. This sign here determines what sign that is. So if everything's positive, we know they're going to be positive. If this B term here is negative, we know they're both going to be negative. Again, we can FOIL that back out. It's worth doing on these first couple. X times x is x squared. X times minus 5x is a minus 5x. Negative 4 times x is a minus 4x. A negative 4 times negative 5 is a positive 20. We see these two terms here combine to give me that middle term in my original expression. Factors of 15. So I'm going to go ahead and do my binomial. So we know it's x times x. Okay, so factors now of 15. Really, it's negative 15. I don't worry about the negative right now. So let's find factors of 15. So we know it can be 5 and 3 or 1 and 15. And once you get pretty good at these, you don't even have to write all of them down because you'll kind of see it. So how can I combine? So when this number is negative here, the question I ask is how can I combine these in any way, plus or minus, so I get this middle term of a plus 2x? Well, yeah, if this 5 is positive, and I'll emphasize that by putting a plus there, and this 3 is negative, 5 times negative 3 is negative 15, and 5 plus negative 3 is a positive 2. So that's your answer, x plus 5, x minus 3. Now, if that 2 had been negative, my signs would have been different. It would have been minus 5, and a plus 3. Again, let's check this out. It is definitely worth forming these back out. It'll really help you learn the factoring process itself. X times x is x squared. X times minus 3 is minus 3x. 5 times x is plus 5x. 5 times minus 3 is minus 15. These here combine to give you that 2x. I get my original expression, so there's my answer. Okay, let's try this one. X squared minus 13x plus 36. Okay, we've done enough now. I think you can pause the video and see if you can do this one on your own. Welcome back. Let's do my 36. And again, factors of 36. Well, I got 4 and 9. Now, again, do we need to list all of them? I mean, I already see 4 and 9. I can combine these to get 13 if both of these are negative. So I can stop there. Now, if I had chosen 6 and 6 first, there's not a way to combine 6 plus 6 to get 36, or to get 13. Or I could have done 12 and 3. So you'll get pretty quick. You'll get quicker at drilling down to these factors. That's going to be x minus 4, x minus 9. I'm going to let you check that on your own. Now, one question I often get asked, what if I got x minus 9 times x minus 4? Is that the same thing? Can I switch the order in which things are being multiplied? We'll try it with numbers. Is 5 times 2 the same as 2 times 5? Yes. Well, what property tells me I can do that? Commutative property of multiplication tells me I can switch the order in which things are being multiplied. And the same thing with binomials. Doesn't matter if this is a binomial. I can switch the order. Does not matter what order we multiply in. So these are exactly the same. X squared plus x plus 10. Again, factors of 10. I've got 5 and 2, or 1 and 10. Can I combine these in a way, adding, subtracting? I know they actually have to both be added because everything's plus. So 5 plus 2 is 7. 1 plus 10 is 7. So what do we know about this one? This one is prime. Okay. Y squared plus 8y plus 12. So again, let's factor my 12. So 4 and 3, nope. 2 and 6, can I combine 2 and 6 in a way to get 8? Well, sure. 2 plus 6 is 8. I'm going to have y plus 2, y plus 6. I'm going to let you check that. It's definitely harder when we have negatives, so let's try this one. I'm going to have negative 6. And how about 3 and 2? So can I combine 3 and 2 so that I get a negative 1? Yes. That 3 is negative and the 2 is positive. So I'm going to factor this as a minus 3, a plus 2. Now, as I mentioned earlier,